Consider an object of mass 50 kilograms. So now we can draw the weight in, okay, acting vertically downwards, of course. Okay, so 50g, placed on a smooth plane which is inclined at an angle alpha to the horizontal. Now it says tan alpha is 5/12. I'll come to that now in a minute. So let's just label the forces. Okay, let's get the forces in. So we've got our reaction here, and remember with the reaction then, we're going to need to draw a dotted line down here. Okay, and remember that angle here is the same as that angle there, so we just label it alpha, okay, because that's what that is, alpha there, and we have the weight component then parallel to the plane as well. So we'll deal with that now. A rope is pulling the object up the plane and acting along the line of greatest slope, so it's parallel, so we've got a tension there. Label all the forces, and it says if the tension in the rope is 250, determine the acceleration of the object. So it's going up the plane. What is this acceleration? Now, in terms of the weight components here, because we've got angle alpha there, remember with the angle, it's going to be cos. We're going to write here 50g. You're just going to have to write cos alpha, okay? And then opposite then 50g sine alpha. We don't know what they are, so we just sort of leave it like that, right? Cos alpha, sine alpha. Having said that, we are told that tan alpha is equal to 5/12. Now, when they do this, what I want you to do is to draw a right angle triangle, okay, like this, and think then of your SOHCAHTOA, okay, your trigonometry. Remember with SOHCAHTOA, if you've got an angle there, and alpha we'll call it, just like the angle here, this will be my opposite side, won't it? Okay, opposite the angle, that's my hypotenuse, the longer side, and then my adjacent there. Now if you remember with SOHCAHTOA, okay, tan for instance, because we get tan here, is opposite over adjacent, isn't it? Tan is opposite over adjacent. Now, in this case, if you look at opposite over adjacent here, the opposite is 5, isn't it? Adjacent is 12. So when they've written it as 5/12, they've given you the opposite side and the adjacent side. So the opposite side is 5, the adjacent side is 12. And what's good, once you've got the two sides, you can then work out what the third side is using Pythagoras. So this squared, add that squared, okay? And then once you've added them, square root it, comes out to be 13, okay? Exactly 13. And what's good about that is we can use it then to work out cos alpha, sine alpha. Because if you think about it, cos alpha, using SOHCAHTOA, well, cos is car, isn't it? So A over H, so it'll be 12/13. Okay, and sine alpha, so will be O over H, 5/13. Okay, so now, when I use now Newton's second law, okay, in direction of motion, we've got tension in the rope, which is 250, taking us up. Take away then the weight component, which is 50g sine alpha, okay, parallel now to the plane, so you've got that going up, that going down, resisting it, equals then to mass times acceleration. Okay, now we don't know what the acceleration is, we've asked to work it out. On the next line, I can sub g to be 9.8, but I know sine alpha, I worked it out, sine alpha is just 5/13, so I can literally get rid of sine alpha now and write it as 5/13, because that's what it is. Okay, so we're not actually dealing directly with the angle size there, we're just seeing what it is in terms of the sine ratio, okay, cos ratio and the tan ratio. So because we got the sine ratio, we just put it in. And then all you've got to do then is, you work that out and then take the 50 over and divide. Okay, so we can do all that in one go, can't we, on our calculator, or just do separate calculations. So maybe I'll work the top out here on my calculator first. Type it in right. So work the top out, divide by 50 then, and I get acceleration out to be 16/13, which is 1.23 meters per second squared.